the ref keyword, passing method parameters by reference. If you haven't watched my previous 2 tutorials on this subject where we talked about stack and heap memory, but also passing by value, then I highly recommend you watch these before proceeding with this tutorial, as they tie into the concepts outlined in this tutorial. So in the previous tutorial, we talked about how various different object types, when being passed as parameters into methods, by default they're passed by value. That meaning a copy of the actual value or a copy of the pointer is created and the method works with the copy. Now I'm going to talk about passing by reference. Now passing by reference is not default behavior, and it includes talking about a brand new keyword called the ref keyword. So how does this work? So just as a little refresher here, we're setting up 2 integers, outputting their values. Then inside this method, we're passing them in as parameters, resetting the values to 0, outputting the variables again. Then when the method is done, we're outputting the value of the original variables. And you can see we're passing these by value. So the method only works with a copy of them. Therefore, the data is never changed once the method has finished completing. So now what I'm going to do is change this slightly. I'm going to pass these value types. Remember, value type is an integer, boolean, simple types stored on the stack. Now I'm going to pass these by reference. And to pass something by reference, you just prefix the variables here with the ref keyword. And in the method parameters here, we do the same thing. So we just add the ref keyword. Now what do you think the output will be? Well, let's take a look. So you can see it's exhibiting the behavior of the reference type from the previous tutorial. Remember when we modified the value of a reference type and it kind of remembered it after the method had been called. Well, this is what's called passing a value type by reference. And we can do this by adding the ref keyword here. So what is the advantage of this? Well, passing a value type inside a method, it doesn't create a copy of the value anymore. So no copy is being created. It's pretty much saying, okay, hey method, I'm going to pass you these 2 variables here. They're value types, but I want to pass you the reference to them in memory. I want you to work with these, and anything you do to them the changes will be reflected. So this is passing a reference to the area in stack memory for these value types. And now they're being passed as reference. We can work with these directly inside the method, and any changes we make to these will be persisted once the method is finished executing. So you can see here I've just changed them, and now the change has been persisted. So you can see now we understand the default behavior in the last tutorial, which is passing by value. It's easier to understand the other terminology which is being passed by reference, and that is using the ref keyword. Okay, so we've looked at passing value types like integers by value. We've looked at passing reference types like complicated objects by value. We've now looked at passing value types by reference. And now to complete the quadrilogy, we're going to look at passing reference types by reference. So here's the example here. We have our list of integers that we looked at before. We just have 4 numbers in there. And then inside this method, we're adding 2 numbers to the list. And then outside, we're just outputting the count of the list along the way. So we looked at this before, and you can see here's the output here. Because by default we're passing a copy of the pointer, but it points to the same area in heap memory, so you can see the changes being persisted once this method has finished executing. But remember when we talked about the fact we can actually set up a new location in heap memory and take a copy of our pointer and give it a whole new location, and that changes the result you can see here. So the change is not persisted in this case. So now I'm going to qualify this with the ref keyword. So I add that here when we call the method, and I add that here in the parameters here. So what do you think is going to happen now? Well, let's take a look. So I'm going to run the application. you can see now the change has actually been persisted once the method has finished executing. So why is this? What's going on here? Well, you may have already guessed it. So when we pass something by reference using the reference keyword, just like we talked about before, we're no longer creating a copy. So we're not even creating a copy of the pointer anymore. We're pretty much passing the pointer in stack memory to this data in heap memory. So we're passing the pointer itself to the method. So the method is now working directly with the original pointer to this information. So now we're setting up a brand new object here, a new list, but we're not working with a copy of the pointer. It's the original pointer. So we're pretty much just creating a brand new list over the top of the original one and then adding 2 numbers to it. So if we run the application now, just like we saw previously, you can see here it's being persisted. So that's the difference here. So when using the ref keyword, we're no longer copying anything. We're not copying the value types, but we're also not copying the pointers when using reference types. So why is this useful? Well, then our methods can work with our original data, whether they're value types or reference types, and the changes can be persisted once the method has finished executing. So that's the power of the ref keyword in C#. And this completes this kind of 3 tutorial series on stack heap memory and reference and value types in C#.